Hello, everyone, and welcome to the Ask the Expert webinar, Model Ops, Why Data Matters, Building Efficient Foundations. My name is Tiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenters. First, we have Luis Flynn, a Senior Product Marketing Manager here at SAS. Luis is an AI product marketer with 20 years of experience in optimizing technology for tactical users. Lou is passionate about helping high-performance teams succeed through alignment of people, processes, and technology. He cultivates a pragmatic, curious culture for winning strategies. We also have Jean de Villiers, a data scientist, head of analytics here at SAS. Jean is a bona fide SAS and AI expert with more than a decade of experience leading data science teams, most recently at Idero Analytics and previously at MultiChoice. He has particular interest in bridging the gap between technology and people. Jean holds a master's degree in business mathematics and informatics from Northwest University and holds the title for the most SAS certifications in Europe. With all of that out of the way, why don't we turn things over to our presenters so we can get started? Lou, please take it away.
All right, so getting started. Model Ops, Why Data Matters. Again, I'm Lou Flynn, working along with Jean de Villiers. Moving forward, so a little bit on our agenda today, right? Data has always mattered, continues to matter. We'll talk a little bit about our data landscape, or the landscape right now. I'll go through a bit of a story about AI. We'll go into people, processes, and technology, a little bit of a skills recap. And then we'll go into Model Ops, take a look at how it's evolving, right? We'll take a look at something called data products, what it is, what it means to Model Ops. Then we'll talk about getting in between seam lines across modeling, best practices, looking at how we could blend in between data products and Model Ops. And then lastly, we'll go into some real world customer wins and have a little bit of a recap. All right. To my esteemed colleague, Jean, go ahead and take it away.
Thank you, Lou. Thank you for handing over. Folks, so I'm going to start off with a very busy thing, and that is generative AI. So today we stand at the forefront of a technological revolution. The progress in artificial intelligence over the past decade has been nothing short of remarkable. Among these advancements, generative AI has captured our imagination and has demonstrated extraordinary potential, transforming the way we think about AI. All right. So what is generative AI and how is it helping us accelerate awareness and perception of AI? So artificial intelligence and the neural network actually originated back in the 50s. And since then, it has come a long way. Originally, we looked at predictive AI, which is more aligned with traditional machine learning. And then it transitioned into generative AI. Now, the big difference why artificial intelligence have exploded over the last 2 decades is the availability of big data as well as computational power, and especially around generative AI. Generative AI leverages massive data sets and a lot of computational power. So the advent of generative AI can, in some circles, be traced back to papers being released in 2017, as well as a bit later. And what you see is the paper got released, and then we had a series of different model iterations all the way through to ChatGPT 3 and ChatGPT 4. And that has really bring generative AI to the spotlight. Everybody knows about it in the modern times. So next we're going to talk about a little bit about real world applications, because generative AI is a nice thing, but unless it gets integrated into our businesses, into our customers' businesses, into the applications, it's not very useful. I like to think about generative AI through the same landscape as the analytics lifecycle, starting from data or data management through to model development, all the way through to decisioning. And what you see here in front of you is 3 examples of exactly that. generative AI is not just limited to large language models. It also plays in the space of synthetic data generation. And synthetic data generation is the process of creating artificial data that mimics real-world data. The data is generated using algorithms and statistical methods to ensure it has similar properties and distributions of actual data. And what we're seeing is that these synthetic data generations, it comes into play with model building where data security or privacy is an issue. There's not enough data. The cost of collecting data is very high, and that's where people start using synthetic methods to generate data. So that's on the data side. And next, on the development side, we see various different tools being integrated into our modern stacks. We see code generation where someone, for instance, comment what needs to be in the code or what the program needs to do, similar to a prompt for ChatGPT, and the code will get generated automatically. We also see the inverse of that, where generative AI can actually summarize what your code is doing. And then lastly, looking at the example at the bottom is on the decisioning layer, generative AI can play an important process in helping provide customer support, enhancing customer support. In this example, you've got a customer that's been a long-standing customer. They've had various interactions. They've made a complaint. And what we want to do is when we react to that, you'll get generative AI to summarize the complaints along with historical interaction data, push that into a system. It will use perhaps predictive analytics to respond with a next best action, and all of that can then be leveraged within generative AI to respond in a nice email, for instance, or whether it's a letter, etc., written out and sent off to the customer. So those are a few good examples. And now we're going to look at some challenges and limitations in generative AI, and actually where this plugs into this Model Ops webinar. So first of all, generative AI comes with certain limitations. We have things such as hallucinations, that's been the front line of news, ethics, transparency, privacy concerns, training costs, all of those things. So what are each of those? Hallucinations, LLMs can produce output that is factually incorrect, not contextual or nonsensical. And it means it doesn't really fit. It's out of context. On the ethics side, we have a few things to consider: misinformation and fake news content. So things that gets generated and advertise the wrong message. That's a bad thing. We've got bias and discrimination. We know that historically the human race, we tend to behave in an unbiased way in the past. And we are slowly but surely as a race correcting that and trying to become more equal across the planet. But that bias and discrimination is still embedded in the data, in the historic data that's being captured. So there needs to be a process on the data side, on the modeling side, as well as on the decisioning side to identify bias and ideally correct it to make things more fairer and more equal. Accountability is a big thing as well. If a decision is generated by a model that is so complex, then it becomes challenging when there is potentially harm that's caused as a result of using the results. Transparency, that's again the black box. It makes it a bit challenging. How are we dealing with that? Privacy violations. When personal data goes into these AI models, it can lead to privacy breaches, and that can again lead to bad results. Finally, training costs. So it's estimated that AI models, to develop a large language model from scratch, costs around $200 million. And to upkeep these models, it's estimated at $700,000 per day for a popular large language model. Per query, it's 36 cents. And then the cost versus traditional search engines is around 10 times as expensive. So there is definitely a cost element around large language models and generative AI that we need to take into considerations. But look, large language models are changing the industry, and like classical machine learning, it benefits from cohesive data management. Today is about applied data practices as part of machine learning workflows in general across a variety of workflows. So it comes down to identifying the use cases that deliver the highest value and solves human needs in a sustainable, scalable manner. And now I'm going to hand over to Lou to take us through a story of data. Thank you.
Thank you, Jean. Thank you for that. Lots of exciting times now. LLMs are all the rage. Let's just talk about data for a bit, right? All right, let's go back in time. I worked for about 10 years supporting public sector here in the US through the DoD and the IC. And I was lucky enough to take part in an organization that grew a data practice pre-buzzwords that started out about 2008, 2009 timeframe when I checked into this organization. We had 4 sites, distributed sites with data coming in. We had about 5 support personnel across the enterprise, consuming dozens of data feeds, right? On the most part, most of this data came in on a weekly basis. We had a guy that sat in a cubicle somewhere and updated all of our data on a Sunday, sent emails out to people. Everyone was fat, dumb, and happy and really enjoyed getting this precious commodity that could help us move on, right? Fast forward across several years. By the time I checked out of this place in 2018-ish, we had grown to dozens of sites. Our measly 5-person data management, data engineering, software engineering personnel grew to 35 people. We grew from dozens of consumers of data to thousands, right? And from there, a bulk of our data was coming in on a more persistent basis. So we saw updates coming in up to near real time. Some data would come in on a daily, maybe weekly basis, but about 95% of the data that we leveraged was coming in piecemeal in near real time. So we were leveraging event processing to ingest a lot of this data. But at the end of the day, what this looked like for our customers was we had data of all different shapes and sizes and velocity. We had an executive team that leaned on the data management personnel, and data management was charged with supporting data to their consumers, right? It wasn't about persisting data to a specific technology. It was not about feeding a certain persona. It was about making data freely available for everyone to use. Didn't know it at the time, but we had some pretty common things that were bleeding edge that you don't see in a lot of different places, right? So how did we do this? We leveraged our people, our process, and our technology in an efficient way, which, by the way, in terms of machine learning operations deployment, is the key, right? Sitting on top of all of this, you have your people, right? Pardon me. This is also the key for organizational improvement. If you want to get inside of a thriving AI maturity model, you leverage your people, your process, and your technology in a very synchronized way. Sitting on top is your people. It's always your most important commodity. It's important how you measure your results. That's your eye on ROI from a business perspective. But org structure comes into play, how you profile and recruit the right type of talent, mindset, expertise, and really the culture that you develop within your organization. Second most important is your processes. How do you vet requirements? How flexible are you to adapt to new capabilities? Your agility, how you, again, adapting to new capabilities, mending processes to improve. Transparency, keeping everyone on the same page, nothing's done in a silo. And then your cadence, how often do you revisit what you're doing? And then last but not least, but kind of sort of least, is technology. On top of your technology stack, you see data. It's the most important commodity within your tech landscape, right? But then you have more factual things that you have to adhere to. Governance, maybe you want to streamline through automation. Interoperability, that's key to supporting a wide variety of users. Traceability, where did your data come from and whatnot. So you have these 3 factors that really weigh in winning with data and MLOps, but really where those things meet, where you see cross-functional work streams, collaboration, dynamic practices, templates, monitoring and best practices, those seam lines right there are the things you need to be successful at if you really want to win, right? Let's take some of these key buzzwords per se. We'll start to hoard them over, archive them, and see how they mash up to modern data practices, okay? You'll see this theme coming across, right? So double click on the people factor here. AI is a people problem. You have a usual list of personas that we work with. You have your data scientists creating models, MLOps engineers deploying them, business analysts leveraging their domain expertise to help make data-driven business decisions, data engineers wrangling complex data sets, IT personnel, you name it, so many different types, and then decision makers that, in a perfect world, trust and leverage the data that's coming down the pipe at your organization. So looking at these roles, how they evolve over time, doesn't matter what we call people. Sure, it can, right? But today, let's focus on a couple of these roles, as I feel they're the most important ones at that intersection, between data engineering and modeling to support, faster, more productive MLOps, right? We'll look at the data scientist, the data engineer, a new role that you hear a lot more about over the last few years, the data product manager or AI data product manager, I've seen them called, right? And see where they fit, in our list of buzzwords, and see how they cohabitate or how they work together to win. So the key here to get these people really rolling, right, is it's interpersonal. Again, the key is your people, not just because they're talented, but because a lot of these work streams are new. People haven't done them before. To succeed in these new type of work dynamics where it's more cross-functional, you need soft skills or these different capabilities that enable people to break down silos, right? Communication, it's early and often. It's not a monthly sync. It's about getting together to understand each other's requirements. It's about stakeholder engagement. These folks across different portions of your organization need to really listen and find alignment across dependencies that aren't within their control. It's about teamwork, right? You want your folks to connect, iterate, and repeat. Again, it's about bringing that cross-functional work stream moving around about as a circle, moving together in one direction. This is kind of the secret sauce here, in my opinion, right? You want to create a culture where people from different factions aren't reacting to things they haven't seen before, right? They're using creative responsiveness, right? They're solving problems in a creative way. And then what that happens is those hard little transactions and iterations between different job functions and different capabilities, you get good at solving these abstract issues that you haven't seen before, all right? And then it's about leadership, right? A lot of these teams, they're not quite as hierarchical as people are used to seeing. They're a little bit more flat, right? You have a bunch of different flavors from different segments of your organization. And it's about stepping up and doing the right thing when no one's looking. It's more about emotional intelligence than it is IQ. So it's EQ over IQ. And it's about shared ownership of your leadership tasks. It's very collaborative, dynamic across the board. And what you get over time is you get a shared vision. Collectively, you get a goal, right? You get an output culture of learning and organizational improvement. These folks that are like the A team just lumped together start to win and understand that they could tackle these different challenges in unique ways. And then that's where you get efficiency in deploying machine learning operations, right? That's where you get good at creating repeatable workflows, moving out of an experiment and getting into repeatable workflows from data engineering side, as well as the model deployment side, right? And these align more to something that we all know, right? Their goals, organizational improvement, and efficiency. We're just applying them to new workflows, right? So let's take some of these best practices, throw them into the buzzword soup, and start to talk about process, right? Process is it's important, right? You have your people, then how they interact is what gets you to the next level, right? You want to keep up to your data velocity, keep up to the speed of your data coming in. Again, you're not working necessarily with your peers, you're working with your peers across the aisle, right? So these teams are cross-functional. Processes will be your link between persona. I mean, this goes for product development as well, right? Consumers, You think about the downstream consumers, like I showed you in our data story, it's about providing them the service they need and the way they need it. So you have empathy for the end user, not for your legacy workflow, right? And we're talking about creating streamlined processes, not shortcuts, right? Cyclical, agile versus waterfall. I'm not adhering for any type of, framework or any type of means of working, but it looks more like agile. It's shorter cycles, small creative ways to increment across a large volume of requirements. Then lastly, you create feedback loops, right? This looks like circles, reiterating, getting feedback back, not lines. And again, you increment, iterate, and move forward slowly, right? So now we've talked about people, we've talked about process. Let's talk about getting things together through model ops. It's a little bit of a dynamic evolution here. So Jean, if you could help me out here, go ahead, take it away.
Thanks, Lou. Thanks for the handover. Folks, let's talk about the analytics lifecycle because it is very applicable in model ops and data products. So to start off with, you always have your business question, your hypotheses that you like to formulate, and that translates through to your data. You need to collect the right data, wrangle the data, integrate it, clean it out. That will then feed into your models. The models very important because they basically the component that drives the predictive elements, the decisioning, and then finally those models need to go into production in order to provide the end users with the right decisions so that we can get to the business value. Now, something has changed over the while. So originally, if we looked at the model ops definition, it was more heavily focused on the right-hand side of this flow. So more heavily focused around the model development and getting those models into production and the governance and the monitoring that goes along with it. Now, the IDC has recently updated definition to include further back towards the data side, the DevOps, model ops, data ops, all of it now combined into a single analytics process. And that inherently has made the challenge for teams a bit more difficult. They need to start focusing on where the data is coming from and not just on the modeling side if you want to get it right. And that's where data products come into play. And I'm going to have you hand over back to Lou that's going to take us through data products and how it applies to the model ops landscape. Thanks, Lou.
Thank you, Jean. Really good. Really interesting how that comes up. I mean, I know you and I were talking about that recently, how, intuitively, the better your data side of the house is in order, the more you can do with it from an insights perspective, as well as a machine learning deployment perspective, right? So kudos to the IDC for expanding that definition, going further left. But let's explore data products. Admittedly, I've used this term a lot. I've looked at it a lot. As a data practitioner, I've been very interested in what the big fuss is, right? So I did what anyone would do. I opened a web browser and I Googled, what is a data product? Unbeknownst to me, Google has a large language model out there called Google Gemini that populated this result for me. And I think there's some snippets in here that are really good. Again, it's focused a little bit more on the digital side per se, right? But Gemini aggregated this result that said a data product is a reusable data asset providing value to users, right? For a specific need or a problem, right? Data assets can be tools or applications that process data to generate insights, made up of metadata, data instances, whatnot, but they're intended to create accessible, consumable, and actionable services, right? I think that's pretty spot on, right? I like to think of the great orchestrators of data services and everything are cross-functional, synchronized teams. And here it's a very digital or technology-focused definition, but it really resonates with me, right? So let's throw those key snippets in to our little aggregate of buzzwords and see where that sits as we move forward. So we've got this Google definition, this Gemini definition of what data products are. Let's take a look at the characteristics of a good data product, right? What those may be. Again, similar to the little story I shared with you from my past, right? Data product characteristics focus on a consumer, or more realistically, they prioritize consumers, right? Through collaboration of data engineers and this data product manager role, which we'll talk about in a little bit, they collaborate to create accessible, self-service data services to a broad variety of users. Data products are repeatable. They create efficient, automated, repeatable processing capabilities, throws away the notion of taking a list or a spreadsheet or a CSV and orchestrating around that. It's thinking of your data as a live commodity that's coming in, and then you're profiling it or figuring out a processing signature of how your data comes in and what you do to invoke it, to everyone else within your organization. Focused on data quality, data cleansing, data triage, data munging, what have you. You have data coming in of all different shapes and sizes. Maybe it's not normalized. Maybe you want to clean it up prior to serving it out to your consumers. But it's about, again, creating that repeatable process and then cleansing data so people can make more sound decisions off data and really gain trust in the process as well as the data. Right. Data products also enhance product by leveraging data enrichment, whether it's bouncing data to different data streams and merging them together from internal resources, or leveraging external data sources. Data products provide you the ability to, again, repeat, again, cleanse, and then lastly, really enrich your data so you have the most up-to-date, cleansed, enhanced data that could feed a number of workflows, right? So how does this happen? Really, it's about mending seam lines. I've really talked about getting in between the processes and the persona, as well as getting between the technology and the people and the technology and the processes. It's really cross-functional, reaching across the aisle in ways that you haven't really done this before, right? Data and AI, there's seam lines and there's constraints beyond what I talked about. Your modern enterprise, or even a more agile, smart, small startup, they're geographically distributed. So there are physical and geographic impediments to success. The right hand doesn't know what the left hand's gonna do if they're in two different continents, right? So here's one of those seam lines that you need to bridge across, right? Organizational. In a lot of organizations, especially the bigger they get, they're not really designed to be cross-functional or collaborative, perhaps, right? A lot of times the engineers sit with the engineers, the analysts sit with the analysts, and then a lot of end users are just onesies and twosies spread out across your organization. So another thing you have to contend with, right? And then workflows, right? You have your data from a MLOps perspective or a data and AI lifecycle perspective. You're looking at the data side of the house on your left, the modeling side in the middle, and then your consumption side at the end, how you deploy your machine learning models to deploy somewhere, or how your users ingest or leverage or understand the insights derived from data, right? I'm going to step aside here, provide a shameless plug. Q3, later on this year, we're going to talk about some of the repeatable elements and how you could configure systems, in our case, SaaS Viya, really to create repeatable workflows and how you can map dependencies so you could really shorten time on this side of the data and AI lifecycle. But today, we'll continue to focus right here. Shameless plug. All right. So moving forward, again, we'll go through and describe what this looks like, accelerating MLOps from the data side, from the organizational perspective with the AI data product manager, data engineer on the left, with the notional workflow that supports both the data scientist and a general purpose user, someone that needs to search and find information from similar data feeds. So how do we mend all of these seam lines to come up with a cohesive, winning data environment that many people could benefit from? Called best practices, right? It's tuning your data practice for the consumers with an S, right? Multiple consumers. And it really, when you break it down, isn't rocket science. you know, it's looking at the same type of workflows that people have already done through a different lens, right? Again, in leveraging your soft skills to close the gap between these people and those portions of the data and AI lifecycle, you could really make things a little more simple, right? Putting a data product manager in the center, right? The effort becomes more consumer focused. He's leveraging IT staff and data engineering people to simply synchronize. Every person involved here has a very specific organizational job that they have to do, right? They have job specific duties. They have things they have to pay up to the greater organization. And again, there's gaps between them. How do we make things work here? It's about extending the thought of your workflow, right? A little bit out and synchronizing, again, moving in circles where the seam lines between different jobs that you are doing start to cohabitate and help each other to move across the way. It's a little bit of a coordination effort here, but with a little bit of thought, a little bit of planning, a little bit of process, you can really accelerate the way people in your organization leverage data to accelerate both the deployment of machine learning and satiate the demand that your variety of general purpose users have with data. And again, it's not just down to these three persona. That's what we'll talk about. But there's a data engineering element, there's a data product management element, as well as, you know, a big consumer element, right? So how do these things cohabitate, right? Let's take a look at this notional workflow here. You have data coming in, right? Maybe it has a little bit of PII in it. Maybe there's some numerical values in here, right? Maybe there are some duplicates of different rows. Maybe there's some redundant data capture. And perhaps in that redundant data capture, there's some issues that create some sparse-ish data, right? So how would this data product manager here help to serve both the data scientists and general purpose users? It's something you've probably seen before. You know, if you've worked on a product team, he uses some of the different prioritization techniques and agility that you see from product management, right? So to mend the seam lines across different data requirements, they sit here firmly between data and model development, and they use their organizational skills to prioritize, right? First, let's see what folks need. So as it turns out in this notional use case, you have 3,200 end users that need to search through, find, and look through this data that's coming in. And you have a handful of data scientists that want to predict the future or create some business value from the numerical information, right? So what the data product manager does is he creates and orchestrates a plan with short iterative cycles. After a few sprints, or throw in your unit of time buzzword here, he comes up with a minimal viable data product, right? Not a minimum viable product if you're on a product team, but a minimal viable data product. And after two short iterations, he's got the data ingest side taken care of, right? He processes the said data to mask any PII. That way, people aren't accessing personal information they shouldn't be privy to in the event throughout their job function, right? Lastly, in the second minimum viable data product, they populate search indices. They leverage a technology like Elasticsearch or Lucene or Solr, you know, to create search indices where general purpose users can now search for their data and their requirements done. It's over. You know, that they're fat, dumb, and happy, leveraging what they need from data to moving forward. And what's interesting here is, since the data product manager is prioritizing along the way, these first few steps are redundant for what the data scientist needs, but without serving the data scientist directly, he's already created repeatable processes that are getting him to where he needs to go, right? So on the next minimum viable data product, right, he deduplicates data to make data better for the data scientist, so he's not looking at dirty data, for lack of a better term. And then, since the data was fairly sparse, he leverages synthetic data generation, really to create statistically relevant imputation that improves the data that they're going to use to train their machine learning model. Maybe he adds another step in here, feature engineering or whatnot, but along the way, he knows what the data scientist needs, and in a short few agile iterations, he's able to serve both the 3,200 3,200 end users that require data for search and their job function, and then also create data that is cleansed and ready to go for a data scientist, right? So before I hand it over to Jean, what I would say here is it seems crazy, and it seems like it's a lot to think about moving forward, but think about advancing AI maturity models. If an organization wants to get beyond experimentation, and then say these data teams aren't in the 5 to 3 dozen zone, if you have thousands of people in your data organization, things get crazy. And this coordination and the flipping the script and putting that product management lens on a group of data practitioners really helps organizations move forward. So without any further ado, I hand it off to Jean to go through some of his use cases that he's gone through over in the UK.
Thank you, Lou. Folks, I'm going to take you through a customer success story, and this is for a UK bank that leverages SaaS Fire. They've got roughly 425,000 customers. They serve individuals, SMEs, real estate, and services, and they've got a fairly large loan book, as well as fairly large customer savings. Thank you, Lou. So what were the issues? So one of the biggest concerns was they knew that they had to modernize the operations. They have to mitigate risk, as well as they have to enhance their customer support. And this is really there for them to survive in the modern state. They were struggling, and they knew they had to change. So these are the 3 things that they had to address. And some of the key issues that got out of this is starting off with digital transformation. They had to embrace digital transformation to mitigate risks, meet regulatory demands. They knew that they had to advance their tools in order to get to model building quicker, testing and deployment faster. And that's really in the model management side. And then they also had a big issue around data integration. They've got an on-premise data center, and they want to leverage open banking as well as open source technology, and they need to leverage all of these tools in a seamless way. So these are some of the big issues. Their desired outcomes were increased agility in a sense of operational, as well as scalability, leveraging the cloud with their partners, technology partners, SaaS Fire and Microsoft Azure. They were looking for a centralized model repository for better governance and traceability with the regulator clamping down on the bank. They were interested in getting to faster insight as well as increasing their productivity. And at the end there, it is around enabling better data practice, optimizing the data access, as well as enhancing collaboration between their talent teams. So these were the issues as well as the desired outcomes. We're going to look at the approach and execution quickly, and it really has 3 pillars. It was from a platform perspective, a standardization, and an automation perspective. Let's look at platform. So what they did is they upgraded their analytics platform, leveraging SaaS Fire for robust data management and model deployment. It provided them with AutoML capabilities. It integrates with open source technologies and facilitates collaboration in a fantastic way. And it empowered their users, the end users, the guys building the models across the various teams to leverage the language of choice. And next, let's look at standardization, because it was quite important moving to a cloud-based system to bring standardization into play. The benefit was model portability, as well as it supported various different modeling personas from your GUI-based modelers all the way to your coders. And really, at the end of the day, it is about, again, standardizing processes and building dependencies between these different environments, so that when you do promote a model to production, that it happens in a seamless way. And then finally, it is around automating. So with scale, with standardization comes automation. First thing is they embraced CI/CD. So, and that's something that's fantastic with the VIA platform. It has that built into it. They knew they had to start leveraging some orchestration technologies, registries, version controlling Git, but at the end of the day, also automating their pipelines, data pipelines, as well as the machine learning pipelines. And that's what they did. And that got them to fantastic wins. Let's look at those wins. And it's framed in a sense of performance, productivity, and trust. From a performance perspective, they had a efficient modeling practice all the way from development to deployment, provided their end users with real-time insights. And they had an environment that's fit for rapid prototyping. That's the Visual Analytics environment, and that's what they leveraged. It resulted in productivity wins, accelerated time to insights and time to value. The whole model deployment process got reduced. So that's faster deployment, faster model validation, as well as model monitoring happens in real time. And leveraging containers and the benefit that comes within, that's the whole CI/CD principle that add a lot of productivity gains to the organization. And finally, probably the most important of the three is trust. Leveraging a centralized repository, it allowed them to enhance their governance, ensures traceability and compliance. It provides a single view around the risk models, and it provided them with the ability to integrate all the various teams into as well as the data flows, data traceability throughout the process end to end, and documented. So that is a tick towards the regulator and their requirements, and that's really a massive win for this customer. I'm going to hand it back to Lou to wrap up this webinar for us.
Thanks, John. Sorry, I was on mute there for a minute. But hey, one of the things I wanted to double click on this one, right, was one of the things he failed to mention, and we were talking about this earlier, but 53% reduction in time to value. You helped to bring this customer from 19 weeks to 9 weeks in terms of deploying their machine learning capabilities from data through deployment. So it's really pretty interesting. This stuff really works. So thanks again, John. That's really good there. So let's summarize what we talked about today, right? So the last word here before we go into some questions, right? Ultimately, analytics, AI, data is a people problem. We run it, right? The best way to go about this is by breaking down the friction between people, process, technology, other different obstacles you might see, like geographic obstacles, cultural obstacles, etc., all in an effort to get out of the science project, improve your AI maturity model organizationally, right? Leveraging these principles, you're gonna decrease the tension between the disparate locations and the disparate people, leveraging soft skills, to work with people you don't necessarily always work with in a traditional context, bringing people and technology together in one unified vision and one unified effort to gain efficiency, right? Get faster access to data. You're no longer leveraging different technology just to bring your data. You have seamless data services coming in when you put the consumer first. And what this does is it creates an ability to organizationally reduce time to value, right? Shorten the data and AI lifecycle. Like Jean did in his previous use case, go from 19 weeks to 9 weeks. Things like that are commonplace when you leverage the right mindset. You probably have the right people You could organize them, leverage strong processes, and then flex your second most important commodity, data, right? First is your people, second is your data. So let's roll out into any questions anyone may have.
On to our first question here. What percentage of data scientists have direct access to production data for model deployment?
That's an interesting question. It's hard for me to say. Jean, let me go with this. Assume none, right? I see a lot of people on the internet all the time saying like, hey, for me to do my job, I need access to production data. Cool. And I agree. You do need access to representative data. You need to know what your data looks like so you can model it and have wins from it. But, you know, a lot of times, like in our customer spaces, we see personally identifiable information. You see there's rules around HIPAA. You know, there's rules about a bunch of different things. So I think a good platform lets you be flexible and lets you create testing environments where you could find parity between your modeling data and the actual production capability, reducing variables between deployment, you know, and your dev box. That's really what it's all about. I think most organizations, it's hard to provide that type of risk, like letting people model against critically personal information.
Gotcha.
Next.
Thank you. Another question here. Is there a reliable protocol to validate the trustworthiness of the data models generated from AI?
John, any thoughts?
That's a very good question. I know that. So I know there's the application of surrogate models, proxies, in order to play a role in identifying whether the response is aligned to what is deemed correct. But I don't know if there's a direct way of doing that at the moment. It's a very good question. What's your take on it, Lou?
Yeah, it's a moving target, right? I think now more than ever, like you described earlier in a presentation, things are moving really fast, and different organizations and then different sectors are more concerned with trustworthiness. I know from what I understand, GDPR had been further ahead of you know, the U.S. regulation of AI, but I know there's a risk management framework that's been put out by the National Institute of Standards and Technology, NIST, right? And there's some basic guidance there, although maybe not legislation. And we've responded at SAS. You know, we have a trustworthy AI workflow at the model level. So when people are modeling in SAS Viya out this month, they have the ability to create trustworthy AI workflows with checks and measures in there where you could notify stakeholders, keeping people in the loop in a human-centric way to ensure or try to enforce trustworthiness, right? Also, we have our model cards. When we create metadata around our modeling, we have the ability, you know, to give a score on the bias, you know, trustworthiness of the individual model. So there are little things like that that are bubbling up as regulation comes online, but it's going to be something that's hard to regulate. And I think when people choose a technology vendor, they'll go with someone who's got values that are in line with theirs. So that's my thought on it.
Thank you. Another question here. Someone's asking, is machine learning the end goal of all data strategies?
I'll jump in for this one. It's definitely a goal. I don't know if it's the end goal. I think the end goal should always be the decision and how it gets applied and used. And also very important, the feedback loop to measure how you're performing, you know, against what you set out as a target or where you should be. So it's definitely a outcome, but it shouldn't be the sole focus. The sole focus at the end of the day should be value. Otherwise, you are still in the experimentation phase. Lou, do you want to add anything to that as well?
Yeah. I mean, I think you're right. As per what we've gone over in our presentation, one of the things I wanted to amplify, and it was kind of in line with what I'm seeing in the market with people using capabilities or concepts like data products, is that all users matter, right? And you strike a balance between feeding predictive capabilities or emerging technologies, as well as providing access to your users so they could leverage data in a way that adds value to the business. Is that always a predictive model? Is that always something that leverages the latest language model? No. Sometimes, like we articulate in a little workflow, we have 3,200 users that are thirsty for data and they leverage data every way. From a data engineering standpoint, why not serve them as part of a plan that could be comprehensive? So machine learning is a goal, but probably not the only goal, and shouldn't be the only goal, depending on where you're coming from.
Thank you. Another question here, you might have touched on this a bit before, but can you explain the role of data quality in ML ops?
I'll jump in for this one, Lou, and then you can add a little bit if you want at the end. So very important, the data that feeds the models, that models get trained on, as well as being scored on, those models are only as good as the data goes into it. So I would say it's of high importance that there's some form of data quality, those steps that happen prior to modeling. It can result in better models. It helps the modeling or the model itself to identify the signal versus the noise if there's higher quality data. So it's definitely one of the most important steps, I would say, that needs to happen in your pre-processing, before you get to model building, if you want to deliver quality models. It's also important that if the data is not accurate, your model will have a result and you'll take action on the basis of that result. And if you think about a customer example, if you have outdated customer information, that can result to a credit card being sent to the wrong customer address, for example. Now, I know that's being covered under GDPR, etc. But that's a good example where data quality plays an important role in the process. So I would say it's highly important. Lou, want to add a little bit to that?
Yeah, it definitely is. Again, use case dependent. But in the little vignette, I provided the story about data organization I helped out with for about 10 years. It's really interesting. So if you look at the balance, I said we started with 5 people, right? And they updated data on a weekly basis. And from a certain perspective, some days your data is 6.5 days old, right? And that kind of sucks, right? But from another perspective, once we started automating and we got these data engineering pipelines coming in and really processing that data at the speed of mission, there were errors, right? So like there's a balance. Like these folks that were processing this data in person had a lot of pride and some great practices in place where there was essentially 0 missing values. They always did everything up to snuff, and but it was a cantankerous manual process. So yeah, the better your data is, I think the more accurate, better your machine learning is going to be. And it's just not automatic, right? As you set up your data engineering practices, you should always strive to do better and critically look at your results and not get discouraged moving forward because, your data could start drifting. Things could come in, something could go wrong in your capture mechanism. But yeah, your data quality matters a lot. And the more you hone in on that and continue to improve, the better you get at it.
Thank you. I'm afraid that's all the time we have for questions today. On behalf of myself, Lou and Jean, and all of SAS, we really hope that you enjoyed today's webinar. Thank you all, and have a great rest of your day.